All right, folks. So we were not able to get through all of the lesson on Wednesday. However, I'm going to go through the entire note session right now, just so you have this as a backup tool for yourself. This is a new software program that Mr. Hager shared with me this morning. So I am giving it a test out right now, and we'll see how it works. So your warm-up right here, after you've had some time to do it yourself, go ahead and watch the rest of this video. If you have not, go ahead and push pause and try yourself, and then you can see as I do. So first we have to identify like terms, and so we're going to go ahead and identify the terms using underlines, right? And so there's one, and then this would be a double underline because it's a constant and a different type of term. We can combine like terms here, so we have 4x minus 3x. Remember to take down the sign that is in front in order to know what operation that you are doing. 4x minus 3x is 1x, or just written as x. This is the standard format without the 1. Since there are no other constants that can be combined, I just bring this down, and my final simplified expression is x plus 2. Moving on to number 2, I'm going to look at another way of identifying like terms, and this is boxes and circles. So I box up like terms that I have, and I can do circles. I can also use triangles if I choose to. So here we go. We have 8y minus 10y. I made sure to bring down that minus 10, right? So it's a negative 10 right here. And minus is a negative. Remember that. A minus is a negative. And so we're right here, and we're saying 8y minus 10y. Well, we have 8 positives and 10 negatives. So it's looking like this. 8 minus 10, if we started a number line on 8, we go to the left 10. We end up at negative 2y. We have negative 3 minus 6, and so if we start at negative 3 and we go further, we can look at this as negative 3 plus a negative 6, which would equal negative 9, and so we'd have a negative 2y minus 9 as our final answer. Moving along, we would have number 3. First, we have to distribute this negative. This is like a negative 1 times 8x minus 5. And so when we look at this, we're saying that negative 1 times 8 and negative 1 times negative 5 would give us negative 1 times 8x equals negative 8x, and negative 1 times a negative 5 would be positive 5 right there. And so we'll rewrite this before we're able to combine like terms. Minus 8x plus 5. And so now we look at this and we say, okay, well, I have negative 2x, negative 8x, I have positive 3 and positive 5. And so I use my lines in order to tell me what I'm going to add together. And so together we have negative 2x minus 8x equals negative 10x. And then we have 3 and 5 together, which would make 8. Our final answer is negative 10x plus 8. All right, and so we're moving on to our first lesson. And the idea today is how can you use algebra tiles to add or subtract algebraic expressions? So this is just kind of like a idea of looking at this as a pictorial versus just the number-wise. The rectangular plus sign is for variables, and these more square plus and minus signs are for constants. And you can see here that we are going back to the idea of 0 pairs. So when we have a plus and a negative, we go ahead and subtract out our 0 pairs, and they kind of poof, be gone. There they went. So first we're going to write this and just, what does this mean? Well, this means x right here. There's 1x, right? 1x. And this is plus 3 constants, right? So together it's x plus 3. And that's our expression that we have right there. The next one, we have 2 positive exponents. We have 2x, and we have a minus 2. So together, they make 2x minus 2. Furthermore, we have 2 positive integers. I'm just using x as our variable. You can use any variable, a, b, c, d, and so forth. But x is kind of the most common. Now here, we have 5 positive constants and we have 2 negative constants. What happens there is we make 0 pairs. And what do we have left? Well, we don't have any negatives. And now we only have 3 positives. So that makes it 2x plus 3. Moving along here, we have 3 positive variables, right? 3x. We have 3 positive constants here, and 2, 4, 6, 7 negative constants. When we make our 0 pairs, what do we have left? Well, we don't have any more of the positives. No longer 7 negative constants, but we have 4 negatives. All right, here we go. Moving forth. We're going to write the sum of 2 algebraic expressions modeled by algebra tiles. Then use the algebra tiles to simplify the expression. Well, first we're going to write it. So what do we see here? We see x plus 2, 1x, and 2 positive constants, right? And right here we see x plus 4. And when we put those together, each expression is going to be x plus a positive x, right? And that positive x comes from right there. And we get our plus from the middle right there. So we end up with 2x. And then the next one, we have 2 positives plus 4 positives, right? And so we have 6. And so our final answer is 2x plus 6. Moving on down here to C. We have right here x minus 5, right? 5 negative constants right there. And we have x minus 2. And watch what happens here. Well, we have the same thing as above. X plus x equals 2x. But now we have negative 5 plus a negative 2, which is going to equal a negative 7. So put those together, and we have 2x minus 7. Make the screen a little bit larger here. So now we have x plus 5, and we have x minus 3. Watch what happens now. We have, 2x minus 3. And so we have x plus 2x. That's going to be 3x. And then we have 5 plus a negative 3. Again, this plus sign is coming from what's in the middle of the 2 algebraic expressions. And so with 5 plus a negative 3, there's more positives than there are negatives. So we'll have positive 2 ending in 3x plus 2. The last one here, we have 2x, 1, 2, 3, 4, 5, 6, 7, 8, minus 8, right? And we're adding 3x plus 1, 2, 3, 4, 5. 5, okay? So we have 2x and plus 3x right there. And so we end up with 2x plus 3x is 6x, negative 8, and positive 5 would give us 3 negatives left over, so 6x minus 3. All right. Moving forth. Make this a little bigger for right now. We're going to write the difference. Now the difference, we were doing the sum, right? Now we're doing the difference, and the difference means to subtract. The same thing here, something new is introduced as a negative variable, right? And we'll look at that on possibly problem D. Let's see, is there anything down there? There is not yet, but we will look at that in a moment. So we're looking right now at x plus 3 minus x plus 1. Okay. Excuse me. What happens here is that this negative right here is being distributed to both of these. So when you see a negative sign, it changes the sign to its opposite. So changes sign to opposite. Write this down. Changes sign to opposite. All right, so we have x plus 3, and then down here we're going to have a minus x minus 1. All right, so it changes those signs to the opposite. And so in the end, we have x plus 3 minus x minus 1. And so our x's are going to go away. 1x there, 1x there. And so we have 3 minus 1 equals 2. Moving along, we have x minus 4. Right, again, it's changing that sign. So we have a minus x, and it changes these signs to a positive, so a plus 3. Right, so it's like subtracting a negative. Subtracting a negative gets a positive, so when we subtract our negatives right here, they turn to positives. What would that look like if we just wrote it out without changing right off the bat? X minus 4 minus x, right, that's a positive. And then we say minus a negative 3. And what happens to these? Well, that becomes a plus right there. So you can see how the x turned to a negative and the negative 3 turned to a positive 3 right there. And our example right here and right here. So moving along, we're going to add those together. We have x minus x equals 0x, or just no x's, right? And we have negative 4 plus 3 equals negative 1, and that would be our final answer there. We have no x's. Moving that down a little bit to make it a little bit bigger. So we end up over here, 2x plus 1, 2, 3, 4, 5, right? Minus x plus 1. Right? Again, this negative is being distributed and changing the sign to its opposite. So we have 2x minus x equals 1x, or x. And then we have 5 plus 1 equals 6. So together, x plus 6 is our final simplified expression. Finally, we have 3x. 1, 2, 3, 4, 5, 6, 7. Right? Minus 7. And again, this negative sign being distributed, so it's going to be a minus, and if we just wrote those as normal, it would be 2x. But what happens there? Minus 2x. And then we change this right here. Those are going to switch to negative, so we have minus 3, right? We're minusing them off, right? So it's minus this whole idea right here. This entire thing is being subtracted from the first part right here, okay? So when in the end, we're going to have 3x minus 2x equals x, and we have negative 7 minus 3 equals negative 10, so x minus 10. Excuse me, x minus 10 did not show up over there. And we are on to the next part right there. All right, and make that screen a little bit bigger. Actually, I'll keep it like that so we see all the problems. All right, so when we're adding these, all right, so we're going to say 2x plus x, right? If it's a positive, the signs stay the same. Signs stay same, right? When it's a negative, the signs change to their opposites. So we have 3x there, and we have a 1 plus a negative 1, which would equal 0. So our final answer is 3x. Again, 2x plus 3x, 5x, negative 6 plus 2, negative 4, together, 5x minus 4. 2x, all right, this negative is being distributed to both of these. We'll change the sign. Minus x equals 1x, or just x. And 4 minus 2 would equal 2. Again, these signs change to negative x minus 2 is what this whole section comes out to be. And so we have our negative x right there and our negative 2 right there. That's where those numbers came from. So in the end, we have x plus 2 as our most simplified expression. Moving along here, we're going to say this negative is going to change that to a negative 2x, right? And then it's going to change this one to a positive 1, right? Different sign. Same sign. Excuse me. Negative sign, we'll change it to its opposite. Negative 1 opposite is positive 1. So then we have 4x minus 2x equals 2x. And we have 3 plus 1 equals 4. So together, 2x plus 4. All right, so I ran out of a little room right there. Moving along to the next ones. Use the algebra tiles to create the following model and simplify it. We have 3x here. We have minus 4 plus, right, a negative x, right? So we think of that as a plus of negative x. And it's also plus, right, 3. All right, so we have 3x minus 4. So 3x plus a negative x equals 2x. And we have a negative 4 plus 3 equals negative 1. So put them together. We cannot combine them. We do not know what x is yet. So we have to leave the constants and the variables separated. All right. I think we're going to skip this page, but we're going to go right to these examples right here. I'll make the screen a little bit bigger. So again, when it's the addition sign, signs stay the same. All right. So we have x plus 3x equals 4x. We have negative 2 plus 8 equals positive 6. Together, written as an expression, 4x plus 6. Right here, negative 4y. Right? Maybe we can look at this as plus 11y minus 5. And we say, okay, we're going to add these ones, and then we'll circle up these ones so we know what we're adding up together. And so negative 4y plus 11y equals 7y. And 3 minus 5, well, 3 positives, and also written as this, 3 plus a negative 5, right? So we can see now that we have more negatives than positives, so it would be a negative 2, so we end up with 7y minus 2. Here we go, we have to distribute before we simplify, so we'll have to distribute that. So it's 2 times a negative 7 and 5/10 z plus a 2 times 3 plus 5z. I always cross my z's so I don't look like 2's in the end. And then against the positive means the signs will stay the same. So we end up with 14, because it's negative 14 z, 7.5 times 7 times 2 is 4. No, sorry. What am I saying? That's 15, right? So 15z plus 6 plus 5z minus 2. We're going to underline twice for our z's, underline once for our constants. We know what we're going to add together. And we have negative 15z plus 5z equals negative 10z. See why z is not the best constant to use. It looks a lot like a 5 and a 2, at least how I write them. And we end up with 6 minus 2 is 4. So together, negative 10z plus 4. All right. Find the sum. We have x plus 2x, 3x, 3 minus 1 is 2. 3x plus 2 is our final example. Remember, when it's the addition sign, the signs will stay the same. Negative 8z plus 4 plus 8z And the idea when it stays the same is we're just putting the plus again and staying like that, so it just stays the same. And so we look at this and we say, okay, identify our like terms. And we have, obviously these are going to cancel out. Let me put that in red so we can kind of see that. And we know that those will cancel out. 8z, negative 8z and positive 8z go to 0. 4 minus 7, or 4 plus a negative 7, if you like to think it like that, would be a negative 3 would be our final simplified expression. Again, the variables canceled out. All right, so we have to distribute before we do anything. And so we'll rewrite this expression as 4 minus n plus, all right, we can say negative 10n, or we can just say a minus, and say plus 6, right? So again, this or could have been 4 minus n minus 10n, right, plus 6. And we're going, now we look at this and say, okay, well, I have my constants, my variables, and my constants. So I know what I'm adding together. Negative 1n minus 10 is negative 11n, right? And if we bring this 4 and 6 together, that's 10. So together, it's negative 11n plus 10. All right, distributing this 1/2 to everything in here, and this 1/4 to everything in here. This problem's going to be kind of messy, but we'll say 1/2 w. When we multiply by a half, it reduces it by half. So 1/2 times 6 is 3 plus 1/4 w. And then what happens down there, I'll show you right here, 1/4 times 12. Right, well, that goes to 3, and that goes to 1. And so our answer is plus 3. We have to change this to a fourth, so we'll change that to a fourth before we do anything. So we have 2/4 w. Right? I see right now that my 3's are going to cancel out, so I'm not going to make a messy situation out of this. I'm going to say those go away. And so then I'll just go back to my w, so plus 1/4 w. And so I get together, I add my numerators, and I get 3. Denominator stays the same. 3/4 w. All right, here's where we get into the tricky part. We have to distribute this to both of our things, and difference, when it's a negative sign, negative changes signs to their opposite. Say it out loud. Changes it to their opposite. All right, here we go. So if we rewrite this equation, 5x plus 6 plus x, right? So that negative 1 times that negative 1x makes it a positive, and that negative times a positive makes this a negative 6. I see right now that some things cancel out. Negative 6 plus 6 cancel out, and then we have our 5x plus x equals 6x. Again, this negative, this is a negative 2 being multiplied by that to that 4 coefficient, and a negative 2 times that 3 constant. So we have 7y plus 5 minus 8, right? Negative 2 times 4 is minus 8y, and then a positive 6. A negative times a negative is a positive. Now we can identify our like terms, and we can add them together. 7y minus 8y equals negative y, and 5 plus 6 equals 11. So negative y plus 11 is our final answer. All right, use the properties of operations to group like terms. We're going to skip that one right now. That's not really important. But we are going to look at these ones right here. Again, this negative is going to be distributed. It's like a negative 1. So negative 1. All right, so m minus 3. Negative 1 times a negative m, well, that gives us a positive m. And a negative 1 times a positive 12, well, that gives us a negative 12. And so we have m plus m, right? So let's actually identify our like terms. m plus m equals 2m, and negative 3 minus 12 equals negative 15. 2m minus 15 is our final answer. We're going to go ahead and distribute this whole negative 2 right there, that whole negative 2 to right there. So it's negative 2c plus, negative times a positive is a negative, right? And so 2.5 times 2 is 5. And this negative 5 is going to be multiplied out right there. So 1.2 times 5. Everyone's got to love decimals. So 10, 5, 6. Right? Decimal goes right there. That's 5 times 1 is 5. So I know the decimal has to go right there. So we say a negative 6c minus 20. Where do I get the minus 20? Negative 5 times a positive 4 is a negative 20. Identify my like terms. Alright, you can use any method, boxes, circles, underlines, or use your colored pencils or your highlighters. So we say negative 2c minus 6c equals negative 8c. Negative 5 minus 20 equals negative 25. So in the end, we have negative 8c minus 25 as our final answer. All right, this one right here. In example 4, you sell the hat for D plus $2. How much do you earn from buying and selling the hat? So you sell the hat for D plus $2. How much do you earn from buying and selling the hat? You sell the hat for D plus $2. I think this is something that I did not include, so this is not something I can do right now. So this is example 4. Let's look back. Oh, so we did miss something. All right. So right here, the original price of the cowboy hat is D dollars. You use a coupon and buy the hat for D minus $2. So the cowboy hat is D dollars. You decorate the hat and sell it for 2D minus $4. Write an expression that represents your earnings from buying and selling the hat. That's a whole bunch of confusion. We're going to go ahead and skip that right now. I'll explain that when I get back, so I have options to show you. All right, if you want to look at these ones, I'll just do these right now. So we have 6x minus 8 plus 2x minus 5. Again, when it's addition, the signs stay the same. We identify our like terms, and we then combine 6x plus 2x equals 8x. Negative 8 minus 5, right? So you look at this as negative 8 plus a negative 5. That helps you think about it as far as what do I have to do here. So 8 plus 5, they're both negative, would be 8, 9, 10, 11, 12, 13. So negative 13. So we end up with 8x minus 13 for that one. And we go over here, and we look right here. We have 2 times 3x, and 2 times negative 4 would be negative 8. Remember this, it's like a negative 1 here, and we're distributing it to both the 2x and the negative 5. And so we end up with negative 2x, and we end up with a positive 5. So when the sign is a negative, the signs change. 6, excuse me, we have right here 2 plus, sorry, I don't know why I have a times there. 2 times 3x. I'm not sure why I did that, but that's going to be a, let's rewrite this equation. We have 6x minus 8 minus 2x plus 5. And so when we add those together, we end up with 6x minus 2x equals negative, so positive 4x, and negative 8 plus 5, and we end up with negative 3. And so we have 4x minus 3. All right, so that's the conclusion of our notes, I believe. Yep, no more pages there for you to do. If you missed any of the notes, or if you needed to look at the notes again and hear my voice, you can fast forward or go anywhere you would like to finish up those notes on the test. You will be able to use your notes. And so make sure that you complete all of these notes, and we'll go from there. Okay, so for the quiz on Friday, I'm going to allow you to use your notes so you have all the support you need to be successful. All right, have a good day.